Okay, it's time. We've learnt about our covalent compounds. We know what Lewis structures look like and how we might put them together, how we might visualize them. Now it's time to learn the rules involved in actually drawing one of these Lewis structures for ourselves. So let's start by going through a process that we can use to draw a Lewis structure for any simple covalent compound. There are several different ways out there that you can follow through to do this. The method that I like teaching is a systematic method that will arrive, or cause you to arrive at your conclusion with confidence every time. So we can follow this same series of steps every single time. I would just quickly like to add that what this set of rules allows us to do is come up with the correct answer in the end. It doesn't show us from a phenomenological point of view how it comes together, merely gives us a means to an end. So our answer will evolve over time. We may make corrections on the way, but when we get to the end, we will have a true plausible Lewis structure for our compound of interest. Let's have a quick chat about these 6 steps that are involved, and then we'll go through a couple of examples together in detail. The first step in drawing your Lewis structures is to draw a skeleton, a general outline for your structure. When we're drawing that, generally the least electronegative element that we have, or elements that we have, go in the center, and the more electronegative ones surround it. One common exception to that rule is hydrogen. Remember, hydrogen only ever wants 2 valence electrons. That's a single bond. You can't have something that wants 1 bond in the middle of something. It just doesn't work. So hydrogen, never in the middle. But otherwise, the least electronegative element belongs. Our second step is to count the number of valence electrons that we have available in our structure. You'll need your periodic table to do this. Remember that if you find an element's in group 2, that means it has 2 valence electrons. In group 7, 7 valence electrons. Nice and simple. So we count up the total number that we have to play with. Then, the third step in drawing our Lewis structures is to use single bonds to join up all of our outlying atoms to that central atom or atoms. Nice and simple. The fourth step in our Lewis structures is to fill out octets around all of our atoms. We want to make sure that everyone can see that stable 8 valence electrons. To do that, we use those lone pairs of electrons. Fifth step in our plan is to then count up how many valence electrons we've used when we've drawn our Lewis structure. And this is a great juncture for us. When we do that check, if that check adds up to the same number we had at the beginning, to the number of valence electrons we had, then we're done. We have our plausible Lewis structure. What I love about this system though is that even when you're wrong, you're still right. If we add that all up and that count fails, if we don't match, it tells us that we need to fix it, but it also gives us feedback on how to fix it. For every 2 electrons we are over that limit, over that count we had, we need to add an extra bond. So that 6th and final step is if our count doesn't add up, we add extra bonds. If we're 2 over the limit, add 1 double bond. If we're 4 over the limit, we can add 2 double bonds or a triple bond. Every 2 we are over, 1 extra bond. So what we're going to do is we're going to break up our skills and our practice exercises into 2 parts. In this topic, we're going to look at structures which don't involve double and triple bonds, so we can get an idea of the basics. And then in the next topic, we'll start looking at compounds that do involve those double and triple bonds, so that you've already got a bit of skill behind you before we tackle them. So let's start with an example now. The first example I have here is ammonia. You likely have some ammonia in your household. Ammonia solutions are very commonly sold commercial cleaning products. So let's go through the steps that are involved and draw the Lewis structure for our ammonia, step by step. The very first step is to draw our skeleton with the least electronegative element in the middle. Remember, hydrogen doesn't count in that process. That's always at the outside. So in this case, we're going to have our nitrogen in the middle, and we'll have our hydrogen around the outside, like so. The next step in drawing our Lewis structure is to count the number of valence electrons that we have available to us. So nitrogen in the middle, that's in group 5 on your periodic table, so it contributes 5 valence electrons. The hydrogen are in group 1, so they each contribute 1, and there are 3 of them. 5 plus 3, we have 8 valence electrons that we're going to be using in this Lewis structure. The next step in drawing our Lewis structure, we join up all of the surrounding atoms to the central one using single bonds. So a single bond between the nitrogen and all 3 hydrogen. Next, we check each atom to make sure they have an octet, to make sure that they can see 8 valence electrons. Now remember, hydrogen is an exception to this. It's one of those very small atoms. It only wants 2 valence electrons, just one bond. They all already have that, so we don't need to worry about them. Look at nitrogen instead. It can see 2, 4, 6 valence electrons. It needs another 2, so we need to add on those extra 2 by adding a lone pair of electrons. So just one lone pair of electrons for nitrogen. Now we do our check. We count up the number of valence electrons we've used in our structure. Check your bonds, check your lone pairs of electrons. We have 2, 4, 6, 8 valence electrons in our structure. When we compare that with our original count, we can see that they are the same, which means that this is a plausible Lewis structure for ammonia. And sure enough, when you look at some previously prepared artistic representations, that's exactly what ammonia looks like. So the next example we're going to discuss together is chloroform. Chloroform's been made famous by the old comic books and some old films. It's what gangsters used to soak a handkerchief in and then hold it over people's nose and mouth and render them unconscious and take them away. We've since discovered it's also a pretty nasty chemical and probably did some permanent damage, but can't be helped now. So if we're drawing our Lewis structure, once again, our skeleton first, the least electronegative element goes in the middle. Now we've got a decision to make. Have a look at your periodic table. Remember, highest electronegativities are up in the top right corner, lowest electronegativities in the bottom left. So we're looking for the element that's furthest to the left and down, not counting hydrogen of course, and that's carbon. So carbon goes in the middle and the other 4 atoms go around the outside. Doesn't matter which one you place where, as long as you have them all around the outside. The next step in drawing our Lewis structure, we need to count the valence electrons so we know how many we have available to us. So hydrogen is in group 1, it provides 1. Carbon is in group 4, provides 4. Chlorine is in group 7, and there are 3 of them. Time to find out how well your primary school timetables went. 7 times 3 is 21, plus 4 is 25, plus another 1. That's 26 valence electrons that we have. On to the next step. We now need to join them all up to the central carbon atom using single bonds. So connecting each of the outer atoms to the central carbon atom. The 4th step, we then need to make sure that each of the atoms can see their octet by adding lone pairs of electrons if we need them. Starting with hydrogen up the top, remember, don't worry about that, only ever wants the single bond. We then look at carbon in the middle. Carbon can see 2, 4, 6, 8 valence electrons, so it's happy just the way it is. What about the 3 chlorine down the bottom? They're all in the same situation. They can all only see 1 bond. That's 2 valence electrons. So to each of those, we need to add 3 lone pairs of electrons, 6 extra electrons, so that they can all see their octet of electrons. They can all see 8. Now, let's move on to the 5th step. We need to check our valence electrons to make sure that our structure is using the correct amount. So we count them up. We've got 2, 4, 6, 8 in the bonds, 10, 12, 14, 16, 18, 20, 22, 24, 26 electrons. And sure enough, when you compare that with your original count, it matches, which means this is a plausible Lewis structure for that wonderful chemical chloroform. And once again, you can see here I've got the artistic representation of a previously prepared Lewis structure. It works out perfectly. So, getting used to drawing these Lewis structures, getting used to these 6 rules, a good thing for you to do. I provided some practice questions and some answers for you in the additional resources so that you can test your mettle for yourself, get used to doing this. Practice makes perfect. Give it a few goes. In no time, it'll seem like second nature. Again, I'm encouraging this system because it's a systematic method. If you get used to these rules, there are no twists, no turns, and no exceptions. You'll be able to draw all of our Lewis structures. Next topic, we'll start introducing double and triple bonds.